Okay, so I'm just going to take you through the whole process all at once really quickly, just so you can see everything that we do all in a row. So first, we'll go to File and we'll open Model, pull up the model we want. So for us, that's in this Setup Files folder. For you, it'll be wherever you decide to put those files. That's the model we want, so we'll go ahead and open that, wait for it to load. So now our model is loaded with the markers that we need. So we have the model there. Now we need to scale it. So we'll go here, Scale Model. The mass of this particular subject was 75.816 kilograms, so we'll change that. We don't need to add markers. Oh, actually, sorry, before we get to that, I forgot. We actually already created a settings file for this, and I'll show you what that is in a minute. So we'll go ahead and load that, Scaling General. And now, 75.816 is the mass of our subject. And then for the market, okay, well, sorry. So what that settings file did, it incorporated these different lengths for the femur and for the tibia of each leg. I'll just go in and look at that real quick. So the femur, we have that it's from the right greater, sort of from the greater trochanter to the lateral knee marker, and then we have the tibia being from the lateral knee marker to the lateral malleolus. And so based on where those markers are, it will scale those specific segments to different lengths. And so we obviously need the static pose in order to get those. And so we need to go into the Leeson toolbox to convert our CSV file to a usable TRC file for that. So let's go back here. So here's our static file, our CSV. So we'll open that, and should be okay. So it should be converted now to a TRC format. So then we can go back to here and find that in subject 9, so PO9 static TRC, that's what we want. And then this one right here will decide where to put the markers. Once again, we'll choose the static pose, or the TRC file that corresponds to the static pose, and open that. And so I think we have everything covered here. We should be good. So let's go ahead and select Run. So let's close down that, and we should be good now. We can see we have our original model and then the scaled model. We only want the scaled model, so let's go ahead and close that original model. So now we're left with just our scaled model. We can work with that. Okay, so now our next step is to do inverse kinematics. However, in order to do that, we have to once again have the marker data and the force data converted over into the .trc and the .mot formats. And so before we do that though, so here's our CSV file, but things are in a slightly different order than they're supposed to be in order to work correctly in the Leeson toolbox. So we have to reorganize them a little bit. So we're going to select those. Oh, actually, sorry. Whoops. So before we move anything, we also want to delete this EMG stuff here. We don't need that for this parting. So we'll delete that, and then we can reorganize this. So these ones we're going to move. So we'll select those columns and move them just over here for now. Let's put them right there, and we'll remove them again later on. So we need to start with the east center of pressure. That's the one that needs to go first. So we'll put that there, and then and then that will be followed by the west center of pressure. So we'll put that next to it right there. After that, we need the east 4, so we'll go ahead and grab that, select it, and then move that over there. Then you'll notice the west force is already next, and that's where it needs to be, so that's great. We don't need to move it. And then we need to have the east moment before the west moment to be consistent, so we'll move that there. And then grab the east moment and move that over. So that those things should be in the right order now. So let's resave this file, but we're going to we'll go ahead and save it under a different name just so we can make sure that we can differentiate. So we'll save it as this one is our original file, and then under dash fixed. So we'll go ahead and save that, and should be good to go. So that's saved in the right order and everything. So now we can go over here, convert data again, go to walking, and choose that file that we just created, and that once again should be good. So we can now go here, go to inverse kinematics, and load the marker data that we just created. We'll then also want to select for it to overwrite this inverse kinematics file. That's just the one that we'll use for holding that motion data. So then we'll hit run, and off he goes. Okay, so that part is done. Just to make sure that we have all of the so we have the ground reaction force going the right direction and everything. Let's right click on here and select associate motion data, and then we're going to choose the MOT file that corresponds to that trial. That way, like I said, we can just make sure that it's all in the right direction and everything. So that should be applied to it. So we'll scan through and watch. It'll be when the right foot hits. Oh, and you will notice that the ground reaction force is pointing down. So that's actually the opposite direction from where it should be pointing. So that was probably another mistake with how our file was formatted. But there's an easy fix for that, thankfully. Go ahead and close that. Yeah, there's an easy fix for that. So we'll go back into this file here, and we just need to times all of the force by -1. So what we're going to do is just put a -1 there, and then copy that, Control C, and then select all of these columns where there's force with both the east and west force. Select it all the way down, right click, and choose paste special, and then do multiply. So that will multiply all of those values by -1, the value we copied. So then we'll hit OK. So all of these should now be multiplied by -1. And then we can go ahead and delete that, and then we'll want to resave that. So we'll save that. And then we once again need to go back into the toolbox and convert that file over to the TRC and MOT format. So let's go back in here. Just to be safe, make sure everything is okay. Let's rerun inverse kinematics with that new file there. And then once again have it override inverse kinematics. That was a file that we created, by the way, and so it's not one that's given to you. So there he goes. And now once again, let's associate the motion data. Make sure that we have this going in the right direction now. So let's scroll through, and now that is going up towards the subject in what we would expect with him pushing against the ground, and so that should be right. So our file's in the right format. Everything looks like it's going okay. So that's it for inverse kinematics. We can now move on to computed muscle control. So first, for the desired kinematics, we'll choose that file that we just created for the inverse kinematics. It has the motion data within it. Then select filter kinematics. For our particular study, we're choosing 6 Hertz. That can be varied depending on the needs of your individual study. But filtering it just, once again, makes it so the curve is a little bit smoother. We'll then select the tracking tasks. So those should come with the model. We just keep them in our setup files folder. So that's this right here. So that's the basic model we're using, and then the tasks task file associated with it. So we'll open that up. The time range is automatically entered in, and then for our prefix, just corresponds to whatever naming system you decide. So for ours, we have it will be P09 because it's subject 9, and then WR, so walking, and the right foot is hitting, and then 05 because it's the 5th trial. And then we can double check here, make sure that this is being saved to the right directory. So subject 9 walking, so that's what we want, open. So now it'll be saved to the right place with that prefix. Okay, moving on here. We need to put in the actuators, or an additional actuator force set file to help the model produce the necessary forces. Make sure that it's set to append the model's force set instead of replace it. We'll then go to add, hit the little folder there, and the file once again should come with the model. For us, we saved it in this setup files folder, so it's that same one, the CMC actuators. So that should be good. Now we need to create the external loads file. So we'll check that box and then hit this button to create new external loads. So here we will then browse for the force plate data. So that's that same MOT file that we used earlier that we associated with the motion. So that for us was this one right here. Remember, once again, make sure you do the fixed version that you just saved. So open that up. Once again, we're going to choose to filter the kinematics, and then we need to actually add the specific forces. So we'll hit add, and now we can create the force. So since it's the ground force, I'm going to go ahead and name it ground, but you can name it whatever you'd like. We then choose the body that it's being applied to. For us, and with this particular trial, the right calcaneus is what is hitting the force plate, so that's where we're applying the force to. So we're going to go ahead and select the right calcaneus. Check the box that it will apply a force. In this case, we want it to be a point force because we want it to be applied at the center of pressure and not just at the origin of that body. And so we're going to select point force, and then here we will select the column from the MOT file that corresponds to the force vectors. And so normally that will be the ones that end in Vx, so the ground force Vx, and then the 1 or the 2 just refers to whether that's the first or the second force plate. And with our data, it's actually the second one. That may be different for you, but so for the force columns, we'll go ahead and select that, the 2 ground force Vx, and it'll automatically put in the Vy and the Vz. And then for the point columns, we do the same thing, but it's the one that ends with Px. So that is the location of the center of pressure. We'll then check the box to apply the torque as well. And then once again, go down here, do the ground torque X and select that one. So we should be good to go with that. So we'll select OK. We'll see that you see now that that force is specified. So now we save that file. And I like to save it as that original file name under -force. So we'll go ahead and do that. Save that file, and so now that's ready to go. So we should have everything ready to go, like I said. Just look it over one more time. Everything should be okay. And so now we can go ahead and select run. And so now it should be starting. This down here will be the progress bar. We can see how far into it is once it actually gets going. If you have to stop at any time, you can select this little X down here in the corner, and that will stop it. If you do that, you will have to completely restart the whole process. But if that's what you need to do, that's fine. So I'm going to go ahead and pause this the presentation, and then I'll restart it again after this is finished running. Okay, so CMC is now finished running, and you can see here it's finished. And just so we can look at it, kind of make sure that everything went okay, we can kind of slide through here, and you can see it kind of alternates between those muscles being red and blue. And so those correspond to the, the activation of the muscles. And so the muscles that are red are being activated, and the muscles that are blue are being activated less. And so you can kind of scroll through that, make sure that it looks consistent with what you would expect. That can be one check to make sure that you did things right. From there, I mean, that's mostly just a kind of a qualitative thing, see if it might have worked or not. We can also do a quantitative analysis by plotting it and looking at the results that way. So we'll open the plotter, and for our study, we're most interested in the individual muscle forces. So what we're going to do is select Y quantity and load file, and then select the actuation force file that corresponds to that trial that we just did. We'll open that up, and then we will select the muscles that we would like to look at. Let's go ahead and just look at the right leg for now for the muscles we want. We wanted to look at 4 different muscles in each leg. The biceps femoris, so we'll go ahead and choose that, specifically the long head. In addition to that, the rectus femoris, the vastus lateralis, and the gastrocmedialis. So we'll select those 4. And for the X quantity, we want to choose time, see how they change over time. Then we select add. And so there are all of the different curves for those 4 different muscles. So that's the basic information. You can also modify things a little bit, to modify the format of things a little bit to suit your own personal needs. For example, we can change, if we change these names down here, then it'll change that over there to what we want. So if we want that to simply say biceps femoris right, then we can type that in and select OK, and then you notice it changes it up there. You can deal with all of them if you would like, or leave them the way it originally had them, either way. Also, if we go into properties, we can change a few more things. So this will be the title of the graph. Let's say we want to name it, so right leg, because it's all the right leg forces together. And then, so that's that general thing. And then you can also change specific things for the y-axis. So for this one with time, for example, on the x-axis, we maybe want to specify that it is in seconds, that the time is in seconds, so we'll add that. And then for the y-axis, instead of just having the names of the muscles there, maybe we want to say, okay, this is the muscle force. So we'll say muscle force, and then specifically it's in newtons. So then that'll change the name of that axis. We can also modify the range of each axis. We have the option of, so it'll auto adjust the range based on the data range that we have, and that's what we've done here to produce this curve. But if you wanted to only have a specific range, say 0 to 500 or 300 to 800, then you could uncheck that box and then manually put in those numbers there. So those are the main keys with plotting. So you then select OK, and you'll notice that those changes have then been implemented. So you can look at the graphs and see if that matches the results that you expected. If you want to look at this outside of OpenSim or use it in use that figure in a paper you're writing, then you can then right-click here, select Export Image, and then choose a place that you would like to export it to. Type a name, we'll say graph, and then select Save, and then you'll be able to, outside of OpenSim, open that file up and look at the graph and use that in your work. So, so that's the basic rundown of how our process worked. Hope that was clear and informative.